The mission is called Prefire, and that stands for the Polar Radiant Energy in the Far Infrared Experiment. Prefire will measure the complete spectrum of emitted energy from the polar regions, and by doing so, help us to improve our predictions of polar climate change.
How about the Arctic?
I think the biggest concern about the Arctic is just how rapidly and how dramatically it's changing. We're seeing changes in the Arctic now that are unlike anything that we've seen in at least the last 300 years. So we're unprepared for those changes, and we really don't know what we're going to need to do to adapt to those changes. Each of our Prefire CubeSats carry something called a thermal infrared spectrometer. The thermal infrared spectrometer is an instrument that looks down at the Earth and gathers energy being emitted from the planet at different wavelengths. The instruments are going to be attached to what we call CubeSats. The CubeSats are about the size of a large shoebox, and the instrument itself is going to take up about half of that space. The real ultimate goal of Prefire is to be able to improve our predictions of 5 to 10 to maybe 50 years from now, so that we can be prepared for those changes and adapt and make sure that the communities that are going to be affected are resilient to those changes. Because the Arctic is changing so quickly, there's a real urgency to getting this information now. We need to have better predictions of how sea level will change, how the weather around the planet is going to change. The only way we're going to do that is to understand how the polar regions are responding to climate change.
These measurements have never been made before. Similar measurements have been made, but decades ago, not nearly as detailed or as careful. And these are new measurements that will be able to provide data that gets applied to the climate models. I'm excited about this mission because I know it'll have a long-lasting impact on the science, and that science is very much directed at the humanity of this Earth. And that these measurements will be around for a long, long time, and that the scientists of the world will be using these to rely on heavily for the next 5 years. There will be future missions that bring even better data. But I think even for 10, 15, 20 years, these measurements will be used by scientists to inform our understanding of the Earth and the processes of heat loss for the Earth. So there was actually a lot of engineering development that went into building this instrument. The instruments are designed at JPL, and they're brought together from components JPL has previously built before, but they needed to be completely re-engineered and scaled down in most cases. So there have been measurements made of the heat lost from Earth, but only heat in certain ranges from the really hotter, warmer temperatures. And yet there's still a lot of heat that's lost from the cooler temperatures, which is what we're really going to be able to measure by going over the poles. And that's such an unknown area of science that the scientists are now building in a theoretical assumption for what is being lost from the Earth. But by making these measurements, we can give them actual data, so they're no longer reliant on their various assumptions about what it is.
Well, NASA studies our home planet more than any other planet, and we use that unique vantage point of space to understand what's happening with our oceans and on land and on ice and in the atmosphere and how those systems work together. And Prefire will be the newest addition to the constellation of over 24 satellites that study the Earth in this way. Prefire is a pair of CubeSats that are flying over the poles, and they'll measure the outgoing energy from the poles in a way that we've never done it before. This is very important because a lot of the energy in the Earth system does escape through the poles, and it's that balance between the energy coming in from the sun and the energy that's leaving the Earth system that really determines where our climate is headed. Well, Prefire is a pair of two CubeSats, and they're flying independently, and that means we'll be able to understand that outgoing energy from the polar regions on a variety of timescales. That's going to help us get better at predicting glacial melt, sea ice melt, and a variety of other features of the Earth system that can help us prepare for the changes that are coming, including helping communities prepare. Prefire's measurements that will help us understand the energy that is the energy exchange in the polar regions will help us better model future ice melt, both the sea ice and the glacial ice that is water that today is trapped on land. When those glaciers melt, when that ice melts, it gets added to the oceans. It's a significant contributor to sea level rise. And sea level rise is one of the greatest challenges for our coastal communities. It can have impacts on the occurrence of sunny day flooding and on the severity of storm surges. So that's just one example of how a better understanding of what's happening in the Arctic affects lives in communities around the world.
Prefire is NASA's Earth science mission to fly two CubeSats, or small satellites, over the polar region. The science from Prefire is going to help us better understand heat loss at the poles and Arctic warming. The Arctic is warming much faster than the rest of the planet, and the information we learn from Prefire will help us better understand those changes and better predict them in the future, including how that impacts temperature, sea level rise, ice sheet melt, and more. So the data from Prefire is going to be used to improve climate models. Climate models are tools that we use to better understand how Earth has changed in the past and to predict changes in the future. And what Prefire is going to do is give us information about this heat exchange between the Earth and space, and we'll be able to use that to improve those models. So the sun doesn't heat the Earth evenly. There's more heat towards the equatorial regions than at the polar regions. And when that heat comes in, weather and currents move it towards the poles, and some of that is emitted back into space. But we've never systematically measured the loss of heat from the poles. And Prefire is going to give us that information so that we can better understand and predict climate change in the future. So the data from Prefire is going to be used to improve climate models. Climate models are tools that we use to both understand changes in the past and also predict changes in the future. And Arctic is warming much faster than the rest of the planet, so we really want to understand that. And some of the processes that are happening in the Arctic, ice melt and formation, snow accumulation, changes in clouds, happen on a very short time scale. And with Prefire, we're flying two CubeSats in asynchronous orbit, so we'll get more frequent measurements from it and be able to observe some of those fast timescale processes and use that to better improve our models and use those for predictions in the future. So Prefire is going to join the more than 24 satellites and instruments in orbit that NASA has that are continually monitoring our planet. These satellites and instruments can tell us things like vegetation, clouds and precipitation, carbon dioxide, and much more. And since we've been observing the planet for decades, we can see both what it looks like today, but also how it's changed over time. And we also use that information to understand how the Earth is connected as a system. So we have satellites that can show us changes in the mass of ice sheets, others that measure sea level rise, and we can use these together to understand how changes in the mass of ice sheets affect sea level rise, and many more examples of how the Earth is connected together.